Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in this week's video I think we'll probably be spending about all of our time over on the lathe. I got a request from a friend to make a knob for him. Most of my videos on my channel are end-to-end projects on the lathe, on the mill, tool making, whatever. This just happens to be one that a friend's made a request to make him a knob. Actually make a couple of them. I'm just going to do one on camera, and I really have no idea what he's going to be using it for. It'll be fairly simple. See if I can get this where you can see it. But the overall diameter, 1 3/4 inches. The depth on it is 1.5 inches, with this protrusion out here being 1 inch, and the knob being knurled and being 1 3/4 inches, ½ inch thick. It will have a 3/8 18 threaded hole 1 inch deep in it. So let's turn around to the lathe and get started making this for my buddy. Okay, hopefully I got you in a position where you can see everything that's going on. I got this piece of stock here. I think this originally started out as 2 inch. Turning rust off of it, it's about 1 7/8 inches now. We need to come down to 1 3/4 inches, and we need to do that for 1.5 inches up the length. This has already got a center in it and has been faced on this end down here. So I'm going to bring the tailstock in and use that center. Let's see what that looks like. All right, I think that's going to be good. So we want to turn 1.5 inches, at least 1.5 inches of this down to 1 3/4 inches. Didn't quite leave myself enough room there. All right, so I'm just going to touch the end here, zero out my Z-axis, come in 1.5 inches, and actually I'm going to come about inch and, I don't know, I'm going to come on 1 3/4 inches, just so I know I got enough room to part or saw it off. Put me a little bit witness mark there. All right, I got a good surface now that's in line with the center that was already in there. So I'll take a measurement. That's 1.867 minus 1.750. All right, so we got 116 thousandths to go. I was trying to key those numbers in the DRO at the same time I was trying to explain to you what I was doing. Looks like I got a piece of stringy material here. All right, DRO says we got about 36 more thousandths. I'm just going to take 30, and even though this outside dimension is not critical, we'll just shoot, trying to get it within 5 thousandths either way. And it looks like 30 thousandths might have been just the right feed and speed or depth to get a chip instead of some long string. So let's see where we are now. Folks, if I was shooting for exactly 1.750, I'm not sure I could have done any better, because that's 1.750 and a half. So I'm happy. All right, our next dimension needs to be 1 inch from the end. That should still be 0, which it is. It will come in 1 inch. Put a little witness mark. And I'm going to go ahead and set my carriage stop down here, because that witness mark obviously is going to be gone in just a moment. So I'm going to take several passes on here and probably just keep messing with the depth of cut until I got it where maybe it's not stringing so bad. And when we get a little closer, remember we're coming down here to 7/8, 0.875. All right, according to the DRO, we got about 100 thousandths left to go. But I've been taking some various different depths of cut, try to find something to stop all those strings. We're looking at 875, 978, so we got 103 thousandths. And let me grab my phone right quick and take a picture. Don't want to move the camera. I want to take a picture right quick of what the DRO says we got left to go. 103.8 is what that says, and the calipers say we got 103. So I'm going to trust the DRO. 20, 40, 60. So I'll take 60 thousandths on this one and then finish up with about 46 thousandths. And that's right to our 1 inch depth. Now what I'm going to do is chamfer this inside. We'll take care of chamfering this when we knurl it. Alright, I'm going to get the drill bit set up and we'll go ahead and drill this inch deep for the 3/8/16. Alright, I've got the bit in now, got the chuck in the tailstock, and got the 3/8 the tap drill for the 3/8/16 mounted. But before I start drilling, I want to say a little bit. I get a lot of questions about my tailstock DRO. You might can see in the video a couple screw holes down here. That's where I had one before, mounted to a ring on the sleeve in the tailstock. But for me, that was just always in the way, and I kept bumping my hand, cutting my hand. Well, not cutting my hand, but just bruising my hand on this piece, this collar that was on here. So I tried something a little different, and this has been on here for a couple years now, and I'm really liking it. I'll try to put a link to this DRO in the description if eBay still sells them. But they're the iGaging brand. AccuMarking is the model. I know a lot of people use calipers, digital calipers, and that's fine. But what I did on this, it comes with this little mounting collar right here that I put 2 screws into the tailstock. Now this arm here, it looks like, I'm looking at my monitor over there and the camera angle looks like it's cocked way back, but it's not. It's actually perpendicular to the Morse taper. I tack welded it onto the Morse taper, just enough to hold it in place, hold it rigid. And then I mounted a little magnet. This is actually a magnet out of an old hard drive. Mounted it here. This has a flat surface right here, so that attaches to the magnet, and it simply follows the quill in whichever direction. So again, I'll try to remember to put a link in the description to this particular DRO. Alright, and what I'm going to do is just pull it up close, tighten it down, and I'm actually going to give a little extra tightening because I found with my tailstock, especially when drilling, that when I put pressure, the tailstock likes to slide back just a little bit. It makes no difference if I'm drilling through something, but if I want to measure the depth, I pretty much have to get the drill started, let the tailstock get seated in place, back it off, and then I usually use my little 6-inch scale in between. But I think maybe I've got it set down now, so I will and at that point right there, I'm going to zero out the DRO. And remember, we said this is going to be a 1-inch deep blind hole. And if you need that accuracy, that's the way you get it with a DRO. Alright, I got a little countersinking tool that's over on the other workbench. Let me go get that and put a countersink in there before we do the tapping. Alright, now I'm going to get the tap, and I am not going to try to power tap this. I'll get it started under power, but then I'll tap this by hand. Actually, it was pulling in there pretty good. I may power tap it a little further. Alright, I don't want to break another tap. when I'm doing something like this, I always like to hit the emergency stop on my lathe as well, just in case something should go haywire with the electrical. Alright, I'm going to back off, and I'm actually going to take my tap back out and put me a little mark on there at where 1 inch is. I just don't want to break that tap off. Okay, that's just a little over 1 inch, but it'll give me some kind of an indication of what to watch for. Again, the tap guide in here is simply to keep everything straight. Alright, this is of course a tapered tap. I'm going to get the bottom tap and bottom it out. Alright, I think that's bottomed out. Alright, what I'm going to do now is carry this over to the bandsaw. I won't try to video that, but I'm going to mount it in the bandsaw. Cut this off just a little over a half. Bring it back. Then we'll face this in and put our knurling on the outside. Alright, our knob workpiece is parted off now, or sawed off. I've got it mounted in a 7/8 inch 5C collet. And of course that's in the hexagon collet block, which fits nicely in a 3-jaw chuck. So what I'm going to do first, I think, is face this outside. Claire, that's as good of a saw cut as that is. I'm almost reluctant to do anything, but we'll do it right. Alright, now these edges are going to get chamfered, but I want to knurl it first. And I'm hoping this clamp style knurler I have will open up that wide. I've got a push type, but I really don't like it. What I'm doing now is just opening it up enough to try to get it on the center. And that looks like it's on center now. So I'm going to turn the RPMs down, put a little clamping on it. Alright, I'll stop the feed or put it in the other direction. Get a little clamping. And since knurling is in fact a cutting operation, I'm going to try to keep some cutting oil on it. I can assure you, you stick a oil brush in there, you're going to lose it. Change directions again. Let's see, I don't believe I tightened it any that time. And what I'm watching for down here is letting about half of the knurling wheel roll off the edge. Change directions. A little tightening. And at this point you can actually blow some of the oil out of the knurl. I think about another couple passes maybe in each direction should be a plenty. All right. Now I'm not gonna tighten this enough to break it, but I want to give it just a little bit more than I can do with my arthritic hands. So change directions. And I think one more time in and out should do it. One more tighten and we'll come out, and I think we'll have a sufficient knurl. I'm very happy with that. Now let's take our chamfering tool. And I think that'll be pretty much the final touches other than just some more brushing on this outside to clean out the knurls. And I usually when I've got something as wide as a ½ inch, whether it be steel or aluminum, that I've put a chamfer on, or that I put a knurl on, I usually give it a pretty heavy chamfer. That chamfer, of course, rolled a little edge over, or that knurling. So what you want to be sure to do, and that's kind of warm right now, is chamfer it enough that you're certain you've got that rolled edge cut off. And then it doesn't hurt either, just to touch that with the file. All right, I think we're ready to take this out and go back to the workbench and do a quick little recap. Well, there you have it. It didn't take us long. Simple little project, but we had some turning, some facing, some drilling, tapping, knurling, and just because I could, I carried it over to the surface grinder and did a little grinding as well. I've since found out, I got to looking back at my notes, and what these are going to be used for is to hold a hatch down. It's on a piece of farm equipment, and I think it's a water tank, a big steel water tank, but it needed something to hold a latch down. Not really sure, but that part really doesn't matter, I don't guess. This is what it called for. I'm going off camera make another one. Hope you enjoyed this. Take care, and I'll see you on the next video.